All right, parallel lines in the coordinate plane. This should be a nice one for you. Learned about lines in Algebra 1. This is around October 6th. The quarter's coming up, the end of the quarter. This should be done before the 9th. Okay, so we have a little warm-up here. It's not highlighted, which means that it's not specifically like this on a test, but that doesn't mean that it's not helpful to us. So you could pause this and try it out, see if you can come up with something. Okay, so when we are adding square roots, we can add up, if they're the same number inside, we can add those together. And 1, 2, 3, 4, 5, so we have 5 of those. So the square root of k is going to equal 5 times the square root of 2. So then we're going to square both sides. We're trying to solve for k. So when we square that, that's going to be k here. And then on this side, this is a product. So when we raise a product to a power, we can distribute the exponent. Now we want to be careful. If there's addition or subtraction in between there, then we cannot distribute it. We have to FOIL. So that's something we want to make sure we're clear on. So if we square that, that would be 25. And if we square a square root, those are inverses, so they basically cancel each other out, so that would just be 2. Now you can think about that another way. The square root of 2 times the square root of 2 would be the square root of 4, and the square root of 4 is 2. So whichever of those works better for you. So that just means that it's from this school called Phillips Exeter Academy, from their Math 1 course. That's a prestigious private school in New Hampshire. And they used to come out here in the summer and do a seminar, and I've got that question from there. Okay, so we're talking about slopes today. Slope, some synonyms for slope are the incline, the gradient, the steepness, the pitch, the rate of change. So the key one out of there would be the rate of change mathematically. We would want to focus on that. Now, in lower math classes, they talk about the rise over the run to try to help kids remember rise over run. But we shouldn't really need that much anymore. You can think about it a little bit. But we do want to associate the letter M with slope. The formula that we're used to is y2 minus y1 over x2 minus x1. But we can also do y1 minus y2 as long as we do x1 minus x2. The key is to go the same way, whichever way you want to use the formula. Another way to look at this is the change in y over the change in x. We use this delta. So that little triangle looking thing is the Greek letter delta. Greek letter delta. Oops. Delta. That's how you say it. All right. All right, so the Coord Railway covers about 3.1 miles and gains 3,600 feet of altitude. What is the average slope of the track? So they're asking us what's the change in y over the change in x. So it goes 3,600 feet in 3.1 miles. So we probably would want to compare the same units to get a better idea of how much it was changing by. So this is called unit analysis, and you'll be doing some of that in chemistry. So we want to get these to be the same, or just have a ratio. So what we might want to think about is if we had 1 mile, how many feet would that be? So you know by now that our system of measurement here in America is pretty awkward. The comparisons of units, 12 inches in a foot, and this is another example, feet in a mile. So I don't know if some of you know that. That's probably a good number to memorize for the rest of high school at least. So those of you who know it have written it down already, and those of you who don't or don't remember, 5,280. So what that means is that this is equal to 1, because 1 mile is 5,280 feet. So we're not changing the value of it. So now we want to do some reducing here. So we can divide 10, reduce this by 10 right there, so that would be the first step. And now I want to start, well, that decimal is a little bit awkward actually. So what I want to do here is actually, I want to multiply these both by 10. So that's going to change that back to 3,600 over 31. I guess I could squeeze the 528 down there also. Okay, so you may be wondering why we did that. It's just we don't want a decimal in a fraction. That's a little bit awkward. Okay, so now we can reduce across here. We can divide by 2. So if we divide that by 2, that's going to be 1,800. Divide that by 2. So when I divide that by 2, I'm going to take 500 divided by 2 and then 28 divided by 2. So 500 divided by 2 is 250, and 28 divided by 2 is 14. So 250 and 14 is 264. Now those are both still even, so I know I can divide them at least by 2. So if I divide them by 2, that's going to be 900. And again, I'm going to divide, well, this one is easy because they're all even. So that's going to be 132. And again, we can, well, now actually, these digits add up to 6. And so when the digits add up to a multiple of 3, we can divide by 3. So if I divide this by 3, that's going to be 300. And if I divide this by 3, it's a little bit trickier. 44. 44. All right, so now we have 300 over 31 times 44. Now, those are both even, but I definitely know 4 goes into 44, and 4 goes into 300 as well. So, because divided by 2 is 150, and divide that by 2 is 75, so divide it by 4 is 75. Divide this by 4 is 11. It's good to practice this sometimes. I know you probably have a calculator sitting right there. You got one on your phone. But it's not good to use the calculator all the time because your skills get a little bit weaker. All right? So, 31 times 11 is going to be 341. So that's going to be 75 over 341. So for every 75 feet it goes up, it goes over 341 feet. Or we could say the same thing about miles, except I doubt the track goes 75 miles. Cog railways are usually to go up mountains. There's one in Pikes Peak in near Colorado Springs, Colorado. All right. So this is more like a test question, although we probably wouldn't just ask for the slope by itself. We would ask for it as part of the equation of a line. But find the slope. So if we're trying to find the slope, we're trying to find the change in y over the change in x. So you take the y coordinates. So I'm going to take y2, which is 7, minus y1. So that's going to be 7 minus 0. And then you need to go the same direction. So I took 7 minus 0, so I need to take 4 minus a negative 3. All right, so 7 minus 0 is 7, and that's going to be plus 3, so that's going to be 7 also. Make sure you always reduce your fractions. You don't have to switch them to mixed numbers, but you do have to reduce when possible. So that reduces. Okay, so write an equation of the line through the point 49 that has a slope of -2. So this actually should be highlighted. This is a test question. Okay. So some teachers in math classes, they try to switch everything to slope-intercept form. So they switch everything to y equals mx plus b. That's not always helpful. A lot of teachers do that because they're trying, because some students have a hard time, so they just try to make it the same for everybody. But the different equations of lines are helpful in different situations. So we want to know all of them. So the key here is that if you take the slope formula, so the slope formula is m equals y. I'm going to leave it as y and then put y minus y1. So when I do that, what I'm doing is I'm leaving this as a variable, as something that's changing. This is a specific point, x1, y1, but this is a variable because I haven't put that subscript on there. Now if we multiply both sides by this to clear the fraction, I get rid of that fraction, and then this is going to cancel out. So I want to rearrange this a little bit. So I'm going to start with the y minus y equals, and then I'm going to switch these around too. So that's called point slope form. When we know a point and a slope, we want to use this formula, at least to start off with. So now, hopefully you can cover this up and do it without looking at that. Use a piece of paper. So it's y and the opposite of y. So that's going to be y minus 9. Okay. And then the slope is negative 2, so you're going to have negative 2. And then x and the opposite of x, that's going to be minus 4. And that's it, and you're done. You don't have to do anything else. Now what a lot of teachers had you do probably is they had you do y equals mx plus b, and then they had you plug in this for x, and this for y, and this for m, and then they had you solve for b, and then they had you write it down again with the b value in there. It's not necessary, unless they ask you to do that, but that's all we need. Okay, so here we're asked, are these two lines parallel? So if they are parallel, that means they'll have the same slope. So what we can do is calculate the rise over the run. So if we look here, the change in y over the change in x. 1, 2, 3, 4, 5, 6, 7. So the change in y is 7. The change in x is 3. So the slope of this line, let's call, oh, that's m1, slope m1. So that's going to be 7/3. All right. Now here, we hopefully can already tell we have a problem here. That's going to be 2, 1. So the slope of m2 is actually 2. Those are not equal. So the answer is no. I guess I could put m1 and m2 in there. m1 does not equal m2. All right, just a future reference to you. When these little dotted lines cross on the grid, those points, that's called a lattice point. Okay, you've seen the lattice before, probably on the side of a building, a wooden, and sometimes vines grow up it, or flowers, or something like that. All right. Okay. So, moving along. P1 passes through those 2 points. Okay, so basically it's kind of the same situation we're just looking at from the graph. So what we want to do is find the slope between these 2 points. So that's going to be, if you always do y2 minus y1, you probably should always do it the same way. Although sometimes it might be better to do y1 minus y2. But I'll just follow the pattern that most people follow there. So y2 minus y1 over x2 minus x1. So that's going to be 1 over 1. So that has a slope of 1. Okay. Now let's do these two here. So that's going to be negative 4 minus 4 over negative 4 minus 5. That's going to be negative 8 over negative 9. So that's going to be 8/9. So those are not parallel because they're not equal. All right. So let's try this last one here. That's going to be 7 minus negative 1 over 3 minus negative 6. That's going to be 8 over 9. Okay, so P3 and P2 have the same slopes. So P2 is parallel to P3. All right, write an equation for a line that passes through that point and is parallel to that. So this is almost the same as the example number 3, I think it was. So they gave us a point. So as soon as they give us a point, we can start writing the equation of the line. So we just talked about point-slope form of a line on the last page. So it's going to be y minus y, was minus a negative 5, so I might as well put y plus 5 equals, then we need a slope, and then it's going to be x minus, oops, y was 0. That's x. So it's a little bit awkward here. I'm going to write it down this time, but y minus 0 and x plus 5. So rarely would we write y minus 0, but since it's notes, I just want to emphasize where that's coming from. So our line is parallel to this line. So we know that we want a slope right here. So parallel means equal, and if y is by itself or isolated, if y is isolated, you know what isolated means, by itself, then the slope is the coefficient of x. Not the x, what's in front of x. So since our line is parallel to that line, it has the same slope. And that's it, we're done. Okay? Now if y was not by itself, then probably what we would do is we would get y by itself. Okay. So find a value of k so that the line through these 2 points is parallel to this line. So again, parallel to this line means that we need to have a slope of 3. So if we calculate this slope, now I want to go this way. So I'm going to do 4 minus, so I'm going to do y1 minus y2 actually. So 4 minus a negative 2 over k minus a negative 3. Because I wanted that k to be positive. And we know that's the formula for the slope between 2 points, and we want that slope to be equal to 3. So 4 minus a negative 2 is 4 plus 2, that's 6. And then we're going to multiply both sides by k plus 3. So that's going to be k plus 3 over here. Alright? Multiply both sides by this to clear the fraction. So now, some of you might want to distribute, and that's fine. You can do that. So if you want to distribute that 3 right there. But I notice that 3 goes into both sides, so I want to divide that out right now. So that's going to be 2, and these 3's will cancel, and I just have k plus 3 left over. So our last step is to subtract 3 from both sides, so k equals negative 1. Alright? So that is the new part of the lesson. Now we're going to do some review, work on some things. So factoring. Factoring is very important in Algebra 2, Algebra 2 honors. You're going to need to know how to factor. So, let's see. This is a couple of special situations. One's called the difference of two squares. They're also the factors that we get are called conjugates, and we're also going to factor some perfect square trinomials. So hopefully you're looking over here and you say, oh yeah, that's a perfect square, that's a perfect square. Suppose we could highlight that. Perfect square trinomials. So now, just because it ends in a perfect square doesn't mean it has to be a perfect square trinomial. It depends on the middle term also. But and the difference of two squares. So one clue that you have the difference of two squares is you have two things, and the other clue is that you're subtracting. Okay. So the difference of two squares is easy. All you do is you take the square root of the first thing. Now, when we factor, we're supposed to ask ourselves, is there a GCF? But there's no GCF for that. So if you square root that, you get x, and if you square root that, you get 7. So it's going to be x minus 7 and x plus 7. And we're done. That's it. So let's, instead of going across here, let's just go down and do these three, and then we'll go do those three. So everybody should be able to pause the video, and you should be able to do this one. If you can't pause the video and do this one, that's not a good sign. You probably weren't paying attention very well. Okay, so hopefully you paused and you came back, and that's going to be x, and that's going to be 8, so it's going to be x minus 8, x plus 8, and we're done. Okay. Now, when we factor, there's supposed to be two things. We're supposed to look for a GCF, and we're supposed to see if we can factor again, question mark. Both of those, question mark. GCF, question mark, factor again, question mark. So here we have a GCF. We can divide both of those by 4x. So we divide that by 4x, the 4 is gone, that's going to be x squared. If we divide this by 4, we're going to get negative 25, and divide by x, that's gone. So we get that. So that's our GCF move. And now we ask ourselves, can we factor again? And yes, we can right here. So factor again. Pause the video. Anytime you know what you're doing, pause. When we get over here, if you know how to do this, pause before I even start it. Okay, so this is going to be x and x. Square root of 25 is 5. That's going to be 5 and 5 minus plus. There we go. All right. So let's move over here. Now, if this is a perfect square and this is a perfect square, then you want to take the square root of this. So the square root of this is 7. And you want to check to see, is this double? If this is double that, then it's a perfect square trinomial, and it factors to x, whatever this sign is, and whatever this square root is, squared. Okay? So, if you follow that pattern, you can pause this, try it yourself. And welcome back. So, if you look at that, the square root of that is 8, and if you double 8, you get that. Now this one's a little bit different. So it's the square root of that is x, and it's this sign. So it's minus, and then it's 8. Now, this is what I was talking about earlier. You cannot just distribute that squared here. It's not x squared minus plus 64, because there's a middle term. So that's where we use FOIL. So we write x minus 8 times x minus 8. We do first, outside, inside, last. But I think we've already talked about that before, so I'm going to keep going. Okay, so again, a GCF. So 4x. So if you divide that by 4x, 4 is gone, and that goes to x squared. Divide that by 4, it becomes 10. Divide x squared by x, it becomes x. Divide 100, that's 25, and the x got factored out. Okay, the square root of that is 5, the square root of that is x, that means it's going to be x, this is plus, so it's going to be x plus 5 squared. We're just following a pattern, we're just memorizing situations. Alright, so down here, anytime you have 4 terms it's pretty good clue that it's factored by grouping. So we have this group and we have this group. So you factor an x squared out of here. That leaves you with x plus 2. Now, whatever you get here, that should be over here also. So that's going to be x plus 2. Now you can subtract a 36 out of there. Now, what's the same in both of those? X plus 2. Okay? So, I don't know how much I want to do at the same time here. I want to do the rest, but... So if I factor an x plus 2 out of both of those, I'm left with x squared minus 36. X squared minus 36. That's the difference of two squares. So hopefully we could do that step together. I guess I won't skip it. Some of you might want to skip this step. So you can kind of see, if you see that that's what we have, then the final step there is that's the difference of two squares. So x minus 6, x plus 6. Okay. Now, again, there's 4 terms here, so probably factor by grouping. So here you're going to factor out an x squared. That's going to be x minus 1, which means we're supposed to get x minus 1 over here. Well, it's a little bit awkward, but hey, we can get that by factoring out a negative 1. Okay, so what's the same in both of those? X minus 1. What's your leftovers? X squared minus 1. What does that tell you? X minus 1. That is the difference of two squares. So that would be x plus 1, x minus 1. However, now there's 2 of those, so that would actually be x plus 1 times x minus 1 squared. Alright, so that's a little bit of factoring review. Now, construct a line through point P that's parallel to line L. So we want a parallel line up here. Okay? So we want a line through point P that's parallel to this. So, step 1, draw a transversal. Okay? Step 1, transversal. Alright. Now, step 2 is to create an arc across that angle. Now, tip, if you do have an actual compass, I'd like to hold the leg of the compass instead of the top up there. Some people like to hold the top. I like to hold the leg, and you're going to turn it to the side so that you can smoothly, if you go straight up and down, a lot of times it rips the paper even. So putting the metal point on the vertex of the angle here. Don't go to P, that's too far. Don't go to P. Alright. And notice how I move I'm moving the paper. I'm pulling the paper around instead of moving this. So what that did is it created an arc across there. So what I want to do is come up here, and I want to create kind of that same arc. And maybe go a little bit further. You need to make sure you at least go as far as it went. Okay? Look at it like that. So we drew an arc across here, and then we moved it up here, and we did the same thing. Now, what we can do is we can use the compass to measure the opening of the angle by putting it across the mouth there. So that's showing us how big that opening is. Now, if we move that up here, we create the same size opening. So we don't want to erase any of those lines, but now by connecting that point to this point, and there's a little bit of margin of error, so that doesn't look perfect, but it's pretty decent. Alright, so in a normal school year, we would be testing that. We test about 1 construction every test. So I will see you next time.